Am I recording it? Yeah, I am. Okay. So we're talking about projectile motion this week, which is usually, it should be covered during the lecture, and that'll be included in the midterm. So that'll be a good review for like this today, I think. So to solve the problem, we're gonna use Dartfish again. You can see the Stone Age computer. So remember to take care of the USB chip. So like, can you guys give me some examples of projectile motion in sports? Yeah, kicking a soccer ball or doing a free throw. So whenever the ball leaves your body, that's a projectile motion. So when it leaves a port with the initial speed, so there's an initial speed, and only the gravity would be acting on the ball. So that's an only force acting on the ball. So everything is determined after it leaves your body. So like the range, the maximum height, the velocity are all determined. You can calculate it because after leaving your body, it's only activated by, it's only influenced by the gravity. So to solve this kind of problem, we need initial velocity and projection angle. So with these initial velocity and projection angle, you can divide the velocity into horizontal and vertical component. We will talk about it later, just give you a quick sense of how we solve this kind of problem. So usually there was no projection height, but if there was a projection height, that'll make the equation a little bit more complicated. So the initial velocity and projection angle is the most important. That makes let you separate the velocity into two directions. So we're gonna use those equations to solve the assignment for this week. And that looks super complicated, but don't worry, we'll try to understand those equations later today. And so those equations are coming from these three equations that's covered in linear kinematics, I think. So those are basic equations. I think you probably need to memorize those things in the midterm. So that'll be final velocity equals to initial velocity plus acceleration times time. That's the most basic one. And also the final velocity square equals to initial square plus 2 acceleration and distance. And also distance equals to initial velocity times time, 1/2 acceleration times square. So those three equations are the basic, and using those equations, we can derive those complicated equations. So we're gonna use the .chem. So to solve this kind of projectile motion problem, the first thing we want to do is to separate the velocity into two components. So there is a velocity, here is an angle, right? We want to separate onto horizontal component and vertical component. And based on trigonometry, the horizontal component would be cosine or sine. Adjacent will be cosine, so we'll say it's V cosine theta. It's a horizontal component. Vertical component will be V sine theta. That's a super important first step. But why do we want to separate into two directions? Why is it helpful for understanding the question? Because we know when the ball leaves your body, there's only gravity acting on the ball, right? And which direction is the gravity acting on the ball? It's downward, right? So the gravity is actually only affecting the vertical velocity. It's not affecting the horizontal velocity here, right? So actually the horizontal velocity will be a constant value throughout the whole motion. And the vertical velocity will be influenced by gravity with a constant acceleration. So that this approach will let us simplify the question. So one is a constant value, the other is a value with constant acceleration. Make sense?
Wait, which one's constant acceleration?
The vertical one, because gravity is acting on it, right?
Okay.
Yeah, so what do we mean constant acceleration? Say you have a vertical velocity here. To simplify the question, we call it V, okay? And after 1 second, what would V be? it'll be v minus gravity, right? V minus g after 1 second, because the acceleration was g, right? V equals to, V equals to V initial minus GT. So every second, the V initial would minus G. So after 2 seconds, that'll be V minus 2G.
So it's V final minus equals V initial minus GT.
Yeah, that's the equation. And we use this equation to solve this kind of problem. So to understand that, like, every second, the gravity will take off some velocity from your initial velocity. If we want to know how long will the gravity take off all your velocity, so we use velocity divided by g, right? So we can know how many times, how long would the gravity take off all your velocity. Does it make sense? Sorry?
Is that 2g at the top?
On the top, yeah, V minus 2g, because that's after 2 seconds. So every second, their velocity will minus 1g. So the first second, velocity minus g. Second, velocity minus 2g. And then velocity minus 3g, 4g, until it's 0. Makes sense? Okay. And why do we want to know, like, how long does the velocity becomes 0? Because on the projectile motion, when does vertical velocity becomes 0? Yeah, exactly. So on the apex here, right? So here, the vertical velocity equals to 0. So the time interval from this point to this point would be V vertical divided by G. So that means how long does the gravity take out all the velocity, right? So that's the time interval here. And we know V vertical velocity will be V sine theta, right? So the time interval will be V sine theta divided by G. Does it make sense?
That's just for 1/2 of the.
Yeah, that's just 1 for 1/2. And the motion is symmetrical, right? So the second half will be the same thing. So your times 2 will be the total flight time. Got it? Okay, cool. So if you look at the complicated equations here, time of flight, you can see here 2v sine theta divided by g. That's the same as what we just got, right? So 2 vertical velocity divided by g. That's a whole flight time, right? Okay. And why do we want to know the flight time? Because to calculate range, we know horizontal velocity is a constant value, right? And the distance will equals to velocity times total time, right? So we can use horizontal velocity times total flight time. You'll get a total range, right? So the time will be this thing. So yeah, this is messed up. Let's write it again here. Range equals to horizontal velocity, VH, times total flight time, T, right? And horizontal velocity would be V cosine theta, right? And then total flight time, we just got it, G 2V sine theta. Makes sense? So that's T, that's horizontal velocity. And you timed up those things together, you'll get a complicated thing, 2V squared sine theta cosine theta. So when you directly look at this equation, that'll be super terrifying. But if you think back to where does that equation comes from, it's actually velocity times time. That's a simple one. So once you got total flight time multiply by your horizontal velocity, you'll get your answer.
Wait, can you, explain that? Like what?
Okay, so we're trying to figure out the total range, right? How far the ball can travel. And the horizontal distance will be related to horizontal velocity, right? Horizontal velocity will be v cosine theta. And on the horizontal direction, there was no gravity, right? So this is a constant value. And we want to know the total distance. So we use this equation, velocity multiplied by time. And the velocity will be v cosine theta, and it's a constant value. And the time will be the total flight time we just calculated. So you put the thing here, you'll get a final answer. But actually this doesn't matter. You need to understand the concept. That's a more important thing. Makes sense. But we know actually the total flight time is only related to the vertical component of the velocity. So once the ball hits the ground, the game is finished, right? So you want to know like how long can the ball be in the air? And the time the being in the air means how long like does it take for gravity to take off all the velocity, all the vertical velocity. So flight time is only related to vertical component of velocity. And the range will related to horizontal component and vertical component. So if you want to throw a ball as far as possible, then you probably heard that you want to throw at 45 degrees. So, because that's a balance point between cosine theta and sine theta. Okay, this is a bit far away, but yeah, so that's how we calculate flight time and how we calculate range. How about maximum height? What kind of motion is on a max to calculate maximum height? Maximum height is on vertical direction, right? That's this distance, h. It's on vertical direction, so it's only related to vertical velocity, right? So you can think about it as you just throw something and how far it can reach. So it's pretty similar to what you have in lab 4, right? The ball dropped on the force plate, and you try to find out H2 here. And you got V2. Gonna figure out H2. If you remember that lab. So anyways, that we'll use distance equals to V initial times time plus 1/2 GT squared to solve this problem. Oh, sorry, it's off. Because there's an initial velocity, and we know how long it takes, right? And we know the acceleration, and want to know the distance. So that's the equation you want to use. Make sense? Okay, so when you plug this thing to time, and you plug V sine theta onto V initial, then you can solve the problem to find maximum height. Makes sense? So yeah, if you look at those complicated equations, that this looks terrifying, but if you think back like how we calculate it, actually time of flight would just be the vertical component of velocity divided by g times 2. So just throw the trigonometry away to look at the equation will make it easier to think about. And the range will be easy. That will be horizontal velocity times total time. And maximum height would be VIT minus 1/2 GT squared. Think about linear motion, and you plug in what you have into the equation. So VI would be V sine theta. That's a vertical component, and T would be this whole thing. So when you plug like trigonometry into it, that makes the equation looks like terrifying, but think about how we get those equations, right? And then this is a super simple example. Usually the projectile motion is like this, like you throw a ball when you're standing up. So there actually this projection height here. They call it h. So like the previous equations only calculate in this interval, right? So the flight time would be something more here. We added some time, right? The flight time would be different. And the total distance would be different, but max and height would be the same. So we want to figure out how different is the flight time, right? So how do we calculate flight time? Actually, the first half would be the same, right? The first half would be v sine theta divided by g. Make sense? That's the first half. How do we find the second half? So we can divide into two phases. This phase will be the same, v sine theta divided by g. I want to know this velocity before we solve all the problems. Sorry, can I say the question again?
What is that last part of the graph?
Oh, so because you're falling like downward than where you take off. So there's a projection height, like when I throw a ball from my body height, the ball will land at the height of my feet, right? So that's different. And that'll make the equation a little bit more complicated. But yeah, so because the motion is symmetrical on the top, right? So if the vertical velocity was v sine theta, the downward velocity at this point will be v sine theta as well, right? Right. And then we can use this equation. V final square equals to V initial square plus 2GH. We're looking at this phase, only this phase, the additional phase. So VI will be V sine theta here, right? V sine theta square plus 2GH will be this 2GH. Then you'll be able to find the final square. Oh, sorry. Yeah, there you go. Right, we're only looking at this interval. So the thing like different from what we just have, the additional thing. Right. And we know at the apex, vertical velocity was 0, right? So we know you can use VF divided by G to get the total time. The same way we're looking at the free falling interval from V equals to 0 until V final that you just calculated. And you divide by G to get the total time. That's how you get it from here. Yeah, that'll be squared. So this VF would be the square root of this thing. So this whole thing, take a square root, divide by G, would be the time interval at the second half. So that's why when you look at the equation here, look at the flight time here. Is that easy to see? Sorry. Yeah, so we look at here, the first circle, V sine theta divided by G. That's this interval, the first half, right? And then the second, third circle here, v sine theta squared plus 2gh, take a square root. That's actually v final we just got here, right? So the second circle is the time interval at the second half of the motion. And you put them together, that'll be the total flight time. Make sense? And the range will be the same thing. You use horizontal velocity times total flight time. So the whole thing times v cosine theta will become this equation. The time multiplied by horizontal velocity will be this equation. So don't be freaked out when you see a lot of like sine and cosine. But when you compare these two equations, the only difference is v cosine theta. So if you can see v cosine theta here and v cosine theta here. When you remove those things, that's the same equation as this one. Makes sense? And how you calculate maximum height will be the same as how you calculate in a simpler example. But the maximum height will be this distance. So when you got the result from here, you need to plus h, plus the projection height. So that's why you'll see the distance was here from a simple example plus the projection height here. Okay. Okay, yeah, it's just for you to get some idea. You don't really need to like understand the whole thing. I know it's really hard. So just give you some thoughts how those equations are coming from. So when you go home, look at the equation, you can think about how to use it and not be freaking out by all the sine and cosine. Okay? Okay, so let me change it. So to solve this kind of problem, we need to divide into vertical and horizontal component and use the linear equations to solve it. Or you can just plug in those equations that already derived, but you gotta know like which means what, right? So how do we find those parameters? We need initial velocity, right? That's really important. And then you use the projection angle to make it vertical and horizontal velocity, right? To plug into the equation. And also you need a projection height in case you need to use a more complicated equation, right? So in case that motion is coming not from the same height as where you land and where you take off. So those are three important components to solve the projectile motion equations. And how do we get it from Dartfish? That's an example. That's a chip shot. So we're going to take the distance divided by time to get the initial velocity, and you use the angle tool to get a projection angle and plug into the equation to solve for, you can predict the range, like how far the ball can travel by the equation. And also, sometimes there's with a projection height. So when she kicks the soccer ball, actually there is a certain height here. So when a ball lands, the range, you need to use a complicated equation. So we can solve the initial velocity, projection angle, and projection height on Dartfish. So that's what we want to measure today. And those are the files we want to use. Yeah, and so that'll be 3.3 throw in and chip shot 3. But if you forgot a number, that's fine, because using those numbers just for me to make my grading easier. Like you got the same answer, but if you didn't, that's fine. So for assignment, it will be one PDF. There are 3 tables in exercise 1, 2, 3. And you need the peak height in exercise 2 that you'll see on the manual. You immediately get it. And there are 11 questions and 1 screenshot. So in the instruction, it's asking you to save your snapshot in every exercise, but actually you don't need to. You just need to save a screenshot for exercise number 3. and you just take a photo of the screen, like what you get, like what I have here for exercise 3, and put it into your lab report. If you're working with 2 in the same group, you can use the same photo. Yeah. And for assignment, the first question is asking you to use trigonometry to break the initial velocity to vertical and horizontal component. And also plug into the equation to calculate like the range and the maximum height. So there will be a lot of calculation, but what you need to include in the assignment will be the equation. So I want to know you understand which equation to use to solve what problem, and also equations with numbers plugged in. So I want to know like if you understand what number should be plugged into which position in the equation, and then the final result. So I want to know if you know how to use the right equation, and if you know how to use that equation and give me the result.
Could you type it, or do you have to?
Both will be fine. Yeah, as long as I can read it. I think handwriting will be easier for you, right? Yeah. So handwriting is acceptable, but if you can type it, that'll make my grading pretty good, my experience pretty good. So yeah, anyways, that's everything for the lab. Any questions for now? Oh, good. Okay, so we're gonna meet outside the gym with, we got 4 computers, so you can have 1 or 2 people in the same group. Yeah. Okay, and with your manuals, all the instructions are on it.